This is section 1.4, composition of functions. In this video, we're going to go through a problem that's really similar to number 11 in your book. So this problem is asking us to solve a variety of composite functions given these two functions here. And the first time you look at this is super confusing. But it's not that hard once you go through it a couple times. And once you go through it a couple times, you become a lot more familiar with it. It's a lot easier. So let's go ahead and go through this. Starting with part A, it's asking for f of g of 1. So we're going to start with this inside part and find g of 1. In other words, plug in a 1 wherever we see an x in our function g of x. When we do that, we get that g of 1 is equal to 3 times 1 minus 4. Oops, this will equal negative 1. And now we have this value for g of 1. So we can say g of 1 is equal to negative 1. And what we do now is find f of this value, negative 1. So f of negative 1 is equal to negative 1 squared plus 5. This will be 1 plus 5 is equal to 6. So our final answer is 6. So first we start with our inside, found g of 1. Then whatever that value was, we plug that into our f of x function and got positive 6. All right, moving on to part B, we're going to do the same thing. So we start with the inside. Inside is just g of x, what we already have. So now we say, all right, wherever we see an x in our outside function in f of x, instead of plugging in x, I'm going to plug in my function g of x. So now this becomes, I have x squared, but I'm going to square my entire function g of x. So this becomes 3x minus 4 squared plus 5. And you can go ahead and simplify this out. This will become 3x minus 4 times 3x minus 4 plus 5. And when you solve all this out, you'll get 9x squared minus 24x plus 16 plus 5 will give us plus 21. All right, moving on to part C. It's just the reverse of what we did in part B. So instead of plugging in g of x wherever we see an x in f of x, we're doing the opposite. We have g of x, and wherever we see an x, we're going to plug in our function for f of x. So now this becomes, I have 3 times x, or in this case, x squared plus 5 minus 4. Simplifying this out, this becomes 3x squared plus 15 minus 4, or 3x squared plus 11. Part D asks us to find g of x. Okay, that's a little confusing, but that just means that we're going to plug x in for our g function, and then whatever we get for that value, we're going to plug that into our g function again. So g of x is just equal to this. So I have g of x is equal to 3x minus 4. And now it's asking me to find g of this thing. So wherever I see an x in my g function, I'm going to plug in this. So my g of x becomes 3. Instead of an x, I'm going to put this function here. 3 times 3x minus 4, and then minus 4 for my g function. And simplifying this out a little bit, I get 3 times 3x is 9x minus 12 minus 4, which simplifies to 9x minus 16 is my g of x. Okay, and finally moving on to our last part, we have something really similar, f of negative 2. So for this, we're going to find what f of negative 2 is, and then plug that value back into our f of x function. So first, our f of negative 2 is equal to negative 2 squared plus 5. This will be 4 plus 5 equals 9. And now we're going to plug this value into our f of x, wherever we see an x. So now that becomes 9 squared plus 5. 9 squared is 81, plus 5 would give me 86. And that's my value for f of negative 2. Okay, so we just went through a bunch of different examples, but hopefully it makes a little bit more sense now. A lot of times you just want to start with this inside part, solve for whatever that value is, then plug that in to the next outside function. Sometimes it can get kind of confusing if you have g of x, but it's all the same thing. We're going to start with the inside, which is just g of x, and wherever we see an x in our original function, we'll plug in whatever this value is, in this case, x. Then whatever our output is for that inside function, we're just going to plug that in to our outside function, which in this case was g of x again. Other than that, that's it for this question, and I hope this was helpful. The concepts covered in this video are true no matter what pre-calc class you're in, but in case you're interested, all the problems referenced in this book came from this lovely book right here. Remember that if you're a Baylor student, we offer free tutoring on the first floor of Sid Rich. You can either make an appointment or drop in whenever you're available to get tutoring in pre-calc, calculus, and a bunch of other subjects as well. Feel free to visit our website for more information.